Yes,
and
sir.
the other part is quantum numbers.
Okay.
Okay. So in history of atomic structure, we have seen a few things. And one of the things that we saw was discovery of electrons, protons, and neutrons. Okay. Now,
Yes, sir.
during the discovery of electron, protons, and neutrons, we also discussed the models. So we have discussed two models till now, Rutherford model and Thomson model. And right now, we are in the conclusion that atom is made something like this. Here we have a very large, this is not very large, atom is very small. But if I compare atom to a proton, which is present, so proton is going to be very small. So whatever discoveries we have discussed till now, we came to the conclusion that proton is in the center of the atom. And in comparison to the atom, proton is very small and the nucleus of the atom is very small and the nucleus is very dense also. It is very dense, small, and positively charged.
Okay, sir.
Okay, that means
Yes,
inside an atom, we now know what is the position of the protons and neutrons. That is inside the nucleus. And the electrons are going to be somewhere here like this. So that we don't know till now. Okay. So
yes,
the only problem that we have right now is to understand the position of electron.
Okay.
Okay. And electron was discovered using cathode ray experiment, cathode ray tube. Now, in order to understand electrons, in order to understand the position of electron, you have to understand the behavior of electron. And majority of the time, what we see or we see the electron in the state of a wave or a in the state of a wave, or we can say rays, okay, or as light,
Yes, sir.
or as glow, something like these terms we can define. Walaikum assalam, Aqib, I am fine, I am good. Okay, fine. So wave, ray, light, or glow, we can understand electrons like this. In order to understand these things, we have to understand waves, right?
Yes, sir.
So today's topic will be completely on waves. So we will first of all understand and revise a few terms about it. I think waves you will be learning for the first time, right? Because in physics it was removed. You guys
Yes,
learned,
sir.
right? Okay.
Yes, sir.
So Akib is here. Is here. No, this is not revision. And this was just for a while. Assalamu alaikum, Amna. Am I audible?
Walaikum assalam, sir.
Okay. Amna, you were present in the last lecture, I guess.
Introduction you have.
You had done only one class, that means.
Yes.
That was the introduction.
Yes.
Okay, fine. This one, right?
Yes.
Okay, fine. So I think I told you, right, that we are discussing history of atomic structure. We are discussing, correct?
Yes, sir.
Okay, fine. So in history of atomic structure, we came to know about the position of protons, but we still don't know what is the position of electron. So we will be studying electrons, and we can study electrons by studying the electronic waves, right? So first of all, we have to understand what is a wave, and then only we can understand what is an electron.
Yes, sir.
So today's class will be completely on waves. So I will wait 3 more minutes and then we will start. I am waiting for 2 more students right now. And if they don't come in 3 minutes, then I will start the class. Okay.
Okay, sir.
It's not necessary, Abdul Hamid.
Okay, sir.
But you need to just answer me whenever I ask him some questions or something. Okay? So you just have to be a bit responsive in the class.
Okay, sir. Okay, sir.
No, Abdul Hamid, not tomorrow. Okay, not tomorrow. And do one thing, Abdul Hamid. Take my number and let me know if you want the lectures of some basic concepts.
Okay, sir.
Okay. So I've sent you my number. Just let me know once if you need those things. If you want to start on your own. So let us start. We'll write the topic electromagnetic waves. Electromagnetic waves. Now, first of all, before electromagnetic waves, what is simple wave also, and what are some terms related to that? We will understand that part. Okay. So this is a wave. Wave must not be new, but the terms may be new. So please see here. Don't write anything right now. Please see. So this is a line which is say we can say that is a normal line, and above we have the highest point is known as the crest, and the lowest point below that line is known as the trough. T-R-O-U-G-H, it is trough. Now the distance between two crests, this is one crest, this is another crest. Distance between two crests is known as wavelength and denoted by lambda. This sign is known as lambda. And also the same thing, distance between two trough is also equal to 1 lambda. And the distance from the normal line to the topmost crest here, it is known as amplitude. Okay. So please write a few terms here and then we will move slowly. Right, number one. Wavelength. Wavelength, it is denoted by what? It is denoted by lambda. What is this known as? L-A-M-B-D, lambda. Okay. Now what is this? The distance between two adjacent crest or troughs. Why not negative lambda for trough? I hope I think you mistook this thing, Akib. This distance is not lambda. Okay. This distance is not lambda. This is the negative part, right? If you calculate this distance, green one. Yeah, I understand. But why it should be negative lambda? The distance is going to be same. Yeah, so also one more thing, please understand everyone, guys. In general, wavelength is what? It is the distance between any 2 points. Any 2 points which are adjacent. For example, let me see. Please see here, guys. This is going upwards. Here it is going downwards, I can say downwards. And here it is going upwards. Here it is going upwards. Right? Here downwards, downwards, upward, upward, and downward. Okay. Now, please, everyone, please listen now. Don't write anything. If I see this point and I say what is the next point similar to this one, you all will say, sir, this is this red point. Is it right? Yes or no? Please tell me. All of you see this is a red point, which is adjacent to blue, similar to blue, but no, that is not correct. Why? Because see, the blue point is going down and the red point is going upward, right? So it is different, right? Okay, so red and the blue one is different. This blue one is similar to this blue one here. Correct, guys? Yes or no? Please tell me.
Yes, sir.
Okay. And if you see the distance between these two also, these two blue, this is also going to be the same. Lambda. You can see all of these things are same. The crest or any 2 point also. Okay. So distance, it cannot be negative. First of all, distance can never be negative. Right, Akib? I hope you understood this, Akib. Distance can never be negative. Distance can be negative. I hope you have learned this in 9th standard motion chapter. Okay, now, crest or troughs. Next thing is that we have to write wavelength, that is distance. So distance will be in terms of some length. Now, length, it is going to be very small because we are talking about electromagnetic waves. So for that, you have to remember a few terms. Okay. So you will remember P and UM. P and this is mu and this is M. What is P? P is for pico. What is N? N is for nano. What is mu? Mu is for micro. What is M? M is for milli. So what is pico? Pico is nothing. It is 10 to the power minus 12. Pico means 10 to the power minus 2.
Minus 2.
Nano means 10 to the power minus 9, 10 to the power minus 6, and this is 10 to the power minus 3. Now, if I have 1 picometer, then 1 means 1. Pico means 10 to the power minus 12, and meter means meter. So I just did what? I just replaced pico with the number that it represents. Similarly, 1 nm, 1 nanometer will be what? 1 nanometer will be equal to 10 to the power minus 9 meters. Right? Similarly, 1 micrometer will be equal to 10 to the power minus 6 meters. And 1 micrometer will be equal to 10 to the power minus 3 meters. Now, there is another term that you have to remember, which is most important, 1 angstrom. 1 angstrom. It is represented as A, and above A, we have a small circle. Okay, so 1 angstrom, it is equal to 10 to the power minus 10 meters. So please read till here. Let me know if you have any doubt. Done, everyone? Yes, please tell me. Moving on, write the next term that we have to understand. Next term is frequency. Please write second term. Frequency. Frequency is given by a cursive V looking letter. It is known as nu. We call it nu. Okay. We call it nu. What is the definition of frequency? Number of waves that passes through a given point in 1 second is called frequency of the wave. And a frequency may not be very new. Sound chapter में आप लोगों ने पढ़ा होगा क्लास 8th में. तो सर बोलिएगा इतना पुराना सर उठा के ला रहे कहाँ से याद रहेगा? But you remember ultrasound? Have you heard this? Yes or no? Please tell me.
Yes, sir.
Ultrasound you have, right? So sound you must have, in that you must have heard about frequency. है ना? So what is frequency? It is a number of waves that passes through a given point in 1 second. I will explain that. First of all, write the unit. Number of wave per second. So number does not have any unit. Second will be per second will be second inverse. And this is also known as what? Hertz. थोड़ा थोड़ा कुछ तो याद आ रहा होगा आप लोगों को. Yes or no, guys? You guys
Yes,
remember?
sir.
Yes or no, please? Okay. Now similarly, see here, okay? Let us suppose we have a wave like this. Okay. Now, what is one wave? This is one wave. This part is one wave. Okay. Complete wave. Okay. Now, if I talk about this point, let us suppose this is a small packet of wave and 20 of such packets pass in 1 second. How many packets? This is one packet complete. Okay. So 20 of such packets pass in 1 second. So what will be the frequency? We will say 20 hertz or 20 per seconds. Got this, guys? Yes or no? Please tell me.
Yes, sir.
Okay. Next point is right here, the velocity. Velocity, or you can also write speed. And velocity for electromagnetic wave is given by c. That is, they travel in the speed of light. Okay. So all of them, they travel in the speed of light. Right here, the distance traveled by wave in 1 second. The distance traveled by wave in 1 second. Right, next. Unit will be meter per second. And next point, all electromagnetic wave that is EMW. All electromagnetic wave travel with speed of light. And what is the speed of light? 3 into 10 to the power 8 meter per second. Write the fourth term. Write the fourth term, amplitude. Is represented by A. Right here. It is the height of crest or depth of trough. Height of crest or depth of trough. Next point you are going to write. A gives an idea about A gives an idea about intensity of, gives an idea about intensity of wave. How intense is that particular electromagnetic wave? Done everyone? Yes or no? Please tell me.
Yes, sir.
Write the fifth one. Wave number. Wave number is given by mu bar. This is mu and bar. Okay. We call this mu bar. What is wave number? The number of wavelengths per centimeter the number of wavelength per centimeter, and it is equal to the inverse of wavelength. Okay, let us understand what is this wave number. Okay, so let us suppose that this distance here to here, from here to here, it is 1 centimeter. Okay, and what is wave one wavelength? One wavelength will be from here to here, right? One wavelength. From here to here, two wavelength. From here to here will be half wavelength. Yes or no? From here to here will be half wavelength, or and from here to here there will be 0.25. This will be 0.75 wavelength. This will be 0.25. So in total, we can say that there are 3 lambdas per centimeter. Got this? Yes or no? Please tell me. उससे आसानी से अगर आपको समझ में नहीं आया, please see. I have taken some bad values here. अगर आपको समझ में नहीं आ रहा, please see here. If I take simple values, just draw the wavelengths first. Let's suppose this is 1 centimeter. Okay, so how many wavelengths are here? This is 1 lambda. From here to here we have another lambda. From here to here we have another lambda, right? So there are 3 lambdas per centimeter. Can I say that? Yes or no?
Yes, sir.
Right. That's it. This is the definition of what? This is the definition of wave number. Got this, guys? Yes or no? Please tell me. And what you can write? Mu bar will be equal to 1 upon lambda. The unit of mu bar will be centimeter inverse. Done, everyone? I hope everyone has written down. Let me know once you're done.
Sir, done.
Okay. Now, right, next, the relations between lambda, nu bar, and the speed of light. Okay, and the speed of light. So what is the unit of lambda? This will be SI unit will be meter, and What is the unit of wavelength? Sorry, what is the unit of frequency? Frequency is second inverse. If I multiply these two, lambda into frequency, lambda times frequency, I will get the unit meter per second. That means I will get what speed? Correct, guys? Yes or no? Please tell me. All of you understood this? हाँ या ना बताएं?
Yes, sir.
Then I can rearrange this. अच्छा, आकिब को नहीं समझ में आया. आकिब, wait. What is the unit of lambda? Lambda will be in terms of meter, right? 10 to the power minus 12, 13, जो भी होगा, meter होगा. Similarly, frequency is going to be what? Second inverse. So this, when you multiply this, you will be meter per second. And you will got it now? So similarly, what you are going to get, I will write, you have to remember like this. Mu is equal to, no problem, Akib, C upon lambda. Mu is equal to C upon lambda. Okay. I can also write mu is equal to 1 by lambda into C. Same thing. I've just separated these terms. Now, what is 1 by lambda? 1 by lambda is nothing but wave number. Right? All right. This sign is for because. I hope all of you know. Right? Because mu bar is equal to 1 upon lambda. Done, everyone? Is on, please tell me. All of you wrote this down? Right, next. Now, before moving to numericals, I will give you some tips. Okay. Now you have this is just tips in order to get correct answer. और यहाँ पे हम trick नहीं बताने वाले how to do fast calculation. If you want to learn how to do fast calculation, I have completed a series of 3 videos in which I tell you how to, quickly multiply by 5, quickly multiply two-digit numbers, to quickly multiply by 11 and all of those things. Okay. Tips for numericals. Okay, so the tips for numerical is that first of all, you will simplify the units. Simplify units. Because there is half marks always for units. Okay, if your examiner in your school, if the examiner is checking according to the CBSE pattern, if they know what is the CBSE pattern of checking, the board's pattern of checking, then half marks is always there for unit. If you get the unit right, you will get half. 0.5 marks you will get always if the unit is correct. Okay. Next is simplify the powers of 10. Simplify powers of 10. For example, you have 10 to the power minus 34 here and 10 to the power minus 19 here. Then you'll first of all simplify 10 to the power minus 34. 19 will go above, it will become plus 19. And this you are going to get how much? Tell me, guys. Minus 34 plus 19. It will be minus 15, right? 10 to the power minus 15. So you are going to do these things first of all. After simplification of unit, you are going to simplify the powers of 10. Next, you are going to simplify the numbers. Simplify numbers. Okay. Last very important tip is that keep fractions as long as possible. Also, the same meaning is that avoid decimals. Between steps. है ना, जैसे मान लीजिए आपको एक चीज निकालनी, you have to get one variable, फिर उसको दूसरे फॉर्मूले में पुट करके दूसरा वेरिएबल निकालना, तीसरा फॉर्मूला. If the first one is in fraction, for example, you are getting something like this, 9/11. तो 9/11 को ना डेसिमल मत रखिएगा, उसको ऐसे ही पुट कीजिएगा सेकंड इक्वेशन. I hope थोड़ा आपको समझ में आ रहा होगा what I'm trying to say. Yes or no? Please tell me. Even though you have not seen any numerical right now, but I hope you understand. If sometimes what you need to do, you need to calculate first part, है ना? ठीक है? and then you have to put it in the second equation. At least you will remember the equations of motions, right? So you get the acceleration from the first equation, then you are going to put it in the third equation, the second equation, right? So if you're getting something in fractions, keep them in fraction. But obviously, if you are having something like this, for example, you have 4/2. तो इसको आप प्लीज इसको 2 लिख दीजिएगा. ओके, सो 4/2 को 4/2 नहीं कीजिएगा, फ्रैक्शंस को सिंप्लीफाई कर दीजिए, बट अवॉइड डेसिमल्स. ओके, अवॉइड डेसिमल्स इन बिटवीन द स्टेप्स. एंड एट लास्ट, all calculations must be done in the same page and with same font. What is the meaning of same font? Same page, I hope everyone understand. You don't have to do any back of the notebook calculation. Okay, back of the notebook calculation nahi honi chahiye, because those calculations se hi the answer aa rahe hain, and you are hiding those calculations. Okay, and if you do any mistake, how are you going to learn upon the mistakes if everything is on the back page? Maybe initially this is the second chapter and you have the back page like this. It's very neat and clean. You have done a few calculations here. But after the end of 4-5 lectures, not 4-5 lectures, 4-5, after the end of 4-5 chapters, you will complete back of the notebook will be completely gejo mejo. है ना? Now what you are going to do? And if you turn the back page to see where you have done the calculation, you will not even remember where you have done the calculation. Okay, so all the calculation you are going to do, just if you have a page like this, let's suppose you have a page like this, then just draw a margin here. Whenever calculation start, draw a margin and do all the calculations here. Okay, so all the rough work will be done in this part. No back of the notebook calculation. Okay, same font का मतलब, हाँ, even if you are doing in the same page, you don't write like this 362 into 8. ऐसे करते हैं ना calculations आप सबको, आया ना? I mean, normally you write this big, but while calculation you write it like this. Correct, guys? Abdul Hamid, Amna, and Aqib.
Yes, sir.
Yes, sir.
You don't have, you will not do this. Okay, because please understand, यही calculations है जिससे आपके answers आने वाले हैं. So why you are treating them some ऐसे कुछ inferior चीज है? आप अच्छे से कीजिए. 362 multiplied by 8. Okay, आराम से तबड़ करने में क्या दिक्कत है ना? बहुत सारे आपके पास जो सिली मिस्टेक क्लास 10th में हो रहे होंगे, वो इसी वजह से हो रहे हैं क्योंकि आप छोटा छोटा लिख लेते हैं, उसी में कुछ ना कुछ मिस्टेक हो जाता था. आप लिख रहे 368 और आपको 6 भी 8 की तरह लिख रहा हो, आप लिख रहे हैं 362 and now this 6 looks like 0 or 6 looks like 8, है ना? I'm सही बात कह रहे हैं, हाँ या ना बताएं आप लोग?
हाँ.
Yes,
है ना?
sir.
अब there is no problem in writing like this ना. आपको क्या करेगा? आपको घर से भगा देंगे क्या? या स्कूल से टीचर हटा देगा? अरे इतना बड़ा कैलकुलेशन कौन करता है? कोई तो नहीं करेगा ऐसे, राइट? सो डू थिंग्स प्रॉपरली. Initially it is going to take a bit of time, but you are going to do so many numericals that वो fastness खुद ब खुद आ जाएगी. ठीक है, चलिए. So these are the tips for numericals in the sense that how to do calculations, simplify the units, simplify the powers. Slowly you will start. You don't have to rush things now. Okay. चलिए, let's first of all write the first question. Write the first question. Yellow light emitted by a sodium lamp. Yellow light emitted by a sodium lamp I mean, it will be better if you write the questions of the beginning. Okay. Yellow light
Okay.
emitted by a sodium lamp has a wavelength of 580 nanometer. 580 nanometer. Calculate the frequency. And wave number of this light. So Abdul Hamid, I think your other subjects are fine. You are having difficulty in chemistry only.
Yes, sir.
Okay. I think that's what I sensed from what your mother told, that your physics teacher or maths teacher told that you can manage 11th and 12th class very easily, right? But in chemistry, you are having problems.
Yes, sir.
That's what I mean. At that time, connection was very bad. I could not hear him. I just have to make up things. Okay, fine. I think they're saying that and they see that. And that's what your mother said, right?
Yes, sir.
Hmm. What does your chemistry teacher say about your chemistry?
She said my chemistry is like basics are weak.
Your physics is also weak.
Huh?
Your physics is also weak.
No, chemistry.
Chemistry is weak. Okay. Fine. So they said that your chemistry is weak. Just that.
Yeah.
Chemistry is difficult. No doubt it is difficult. And it is also very different from the other subjects that you do. Biology, you will, I mean, if you see the chemistry that you are learning now, it has no relation with whatever you have learned in 9th standard or 11th, 10th standard, right?
Yeah. Yes, sir.
Mm. But in physics, you may see some relation from the 9th standard. Motion chapter, kinematics is there. Hai. Then laws of motion is also there in 9th. So some similarity are there, but chemistry is completely different.
Yes, sir.
And most people, they just have a misconception that 9th standards, like I can say, widened version in 11th standard, but that's not chemistry. You are learning chemistry for the first time. Keep it like that. Okay. So please solve. I hope this is easy. You have been given everything right now. You have been given the lambda, which is equal to 580 nanometer. And you have been asked frequency, right? So what will be the frequency and what will be the wave number? And you already know what is C. This value you have to remember, 3 into 10 to the power 8 meter per second. But I hope from the chapter light reflection and refraction, you may remember this, meter per second. Just see that you are having your units aligned. I hope you learned that in the chapter of physics, unit dimension and measurement, that units should be proper whenever you are doing any calculations. Check. And let me put up a timer. I will give you 3 more minutes, okay, to complete the calculations and everything. And you guys can let me know if you get stuck anywhere. Anyone done? Abdul Hamid, Amna. Time is over. Yes, guys. Are you stuck? What happened? At least say something, no, sir. I'm stuck. Abdul Hamid, tell me.
Sir, for the first step, we have to find nu, right? Nu equal to c by lambda.
Yes, that's it. Yeah.
I got the answer as 193.33 into 10 raised to 5.
Units. First of all, you have to solve the units. After units is solve nahi kiya.
Oh,
U will be equal to c by lambda, right? C is equal to what? 3 into 10 to the power 8 meter per second,
meters
right?
second.
Divided by lambda is what? 580 nanometer. What is nano? 10 to the power minus 9 meters.
Yeah, for that.
Right? Now meters and meters will cancel each other out. You are going to get 3 into 10 to the power 8 divided by, now 580 I can write 58, है into 10 to the power minus 8.
Minus 8.
Right? And this will be what? Second inverse. अब आप second inverse को भूल जाइए. ठीक है? Second inverse यहाँ पे मिल गया ना आपको. Now you can forget second inverse because you have solved. Your answer is going to be in second inverse. That's it. And that is also correct because frequency will have a unit of second inverse. Now you can further write this as 3 into 3 divided by 58 into 10 to the power 8 plus 8. Right? Minus 8 will go above. It will become plus 8. This will become what? 3 by 58 into 10 to the power 16. Now 3 upon 58 will be approximately how much? Tell me, guys. Will be approximately 0.05.
Okay.
Because it is 3 upon 50 is very near to 3 by 16. Right? This will be 1 by 20.
Okay.
So this will be 1 by 20. So 1 by 2 is 0.5. So this will be 1 by 2 into 10. Okay. Approximately I can write 0.05 into 10 to the power 16. This will be equal to 5 into 10 to the power 14 second inverse, or you can write this as 5 into 10 to the power 14
meter per second.
Hertz.
Hertz, okay.
Hertz. Akib, what happened? Akib and Amna, I can't hear you at all. कुछ बोल ही नहीं रही हैं आप. Amna, am I audible?
Yes, sir.
You did this one, yes or no? Tell me.
Yes.
You got the answer correct?
Yes.
So when I was asking, did you do this or not? Why did you not turn your mic on and tell me, sir, I have done. This is the answer.
Sir, I was doing that.
Acha, okay, fine. Find the wave number then. You can find the wave number, right? But please remember, wave number will be equal to 1 upon lambda. And this lambda should be in centimeter, okay? So you have to convert 580 nanometer into centimeter first of all. Chaliye, please write this down.
Sir,
Yes, I'm
how to convert it in centimeter?
in centimeter. हाँ, ये प्रॉब्लम आ रही है, देखिए अब कन्वर्जन में यू विल नॉट नेवर हैव एनी प्रॉब्लम, ठीक है। सो कन्वर्जन का आप लोग अप्रोच ही चेंज कीजिए, ओके। वी आर गोइंग टू चेंज द अप्रोच टू कन्वर्जन very simply. See here guys, I will write 1 upon what is lambda. Lambda is
580
580
10 raised to minus 9.
नहीं वो ठीक है, चलिए, लेकिन याद करने वाली चीज होगी ना, आपको अप्रोच बता रहे हैं। 580 इंटू 10 to the power minus
minus 9.
9
9.
मीटर, करेक्ट
हाँ.
है ना। आई कैन राइट द सेम थिंग, 580 into 10 to the power minus 9. What is 1 meter? 1 meter is how much centimeter? 1 meter is how much centimeter? Tell me guys.
100.
ये सबको याद है या ना? आमना टेल मी, याद है?
जी.
100.
है ना, 100। तो मीटर के बजाय क्या लिख सकते हैं हम?
100.
into 100 centimeter. Okay.
है ना, हमने कुछ मल्टीप्लाई नहीं किया, मीटर को कैसे लिख दिया? 100 सेंटीमीटर लिख दिया। गॉट दिस? यस और नो? आमना टेल मी।
Yes.
है ना। वैसे समझिए जरा, देखिए ये अप्रोच जो है ना, इसको ध्यान रखिएगा प्लीज। जैसे आप लोग कहते हैं ना, जैसे 5 kg है, 5 kg को कन्वर्ट करना है ग्राम से, कन्वर्ट भी ना करना है, कन्वर्ट करना ही नहीं है। दिस ये के है ना, के का मतलब क्या होता है? के का मतलब होता है 1000। ऐसे देखिए ना, के जी आ जाए चाहे के मीटर आ जाए, किलोमीटर, किलो का मतलब होता है 1000। तो बस आप 5 लिखिए इंटू, है ना, इंटू ही तो सारा, इंटू 1000, यानी कि आपने मल्टीप्लाई नहीं किया, आपने के की जगह क्या लिख दिया? 1000 लिख दिया, और ग्राम का ग्राम। ठीक है, तो इसमें ना आपके पास क्या होगा कि डिवाइड करना या मल्टीप्लाई करना, ये कंफ्यूजन खत्म हो जाएगा। ठीक है, कि केजी से ग्राम में कन्वर्ट कर रहे हैं अगर, तो आपको कन्वर्ट कुछ नहीं करना, के का वैल्यू लिख देना है, दैट के मींस 1000, दैट्स इट। गॉट इट आमना? यस और नो? टेल मी।
Yes.
ठीक है, चलिए अब कर लीजिए, कितना आ जाएगा आंसर? अच्छा, हम लोग वेव्स क्यों पढ़ रहे हैं वैसे बताइए, अब्दुल हमीद, आमना एंड आकिब? व्हाई आर वी लर्निंग अबाउट वेव्स? अरे बोलो भाई। हाँ, अब्दुल हमीद, व्हाई आर वी लर्निंग द वे, व्हाई आर वी लर्निंग अबाउट वेव्स? नो आइडिया सर, ठीक है, आकिब को नो आइडिया। हमने समझाया तो था, आमना बताएं।
पोजीशन चेक फाइंड करना है.
किसका?
न्यूक्लियस.
न्यूक्लियस को तो पता चल गया कि वो बीच में बिल्कुल बहुत छोटा होता है, बहुत डेंस होता है, पॉजिटिवली चार्ज होता है, राइट। वी वांट टू नो
जी.
द पोजीशन ऑफ इलेक्ट्रॉन, करेक्ट।
इलेक्ट्रॉन.
और now we can only manipulate the wave nature of electron, because electron as a particle is very small, but waves we can see, है ना। और Akib, I don't know whether you were present or not, I also showed the cathode ray experiment. आमना आप भी नहीं होंगे, है ना, बट इस क्लास में 2 और लड़कियां थी, रिशिता एंड अफाफ, आज नहीं आई हैं। आकिब थे कि नहीं थे? है ना। तो इलेक्ट्रॉन के सिर्फ हम लोग लाइट्स को दे सकते हैं, दैट इज व्हाई वी हैव टू फर्स्ट अंडरस्टैंड अबाउट वेव। और वेव में हम लोग कुछ एक्सपेरिमेंट करेंगे, जब तक हम लोग वेव्स को समझेंगे नहीं तब तक एक्सपेरिमेंट करके क्या समझ में आएगा। सो विल डू सम एक्सपेरिमेंट्स ऑन वेव्स एंड देन वी विल अंडरस्टैंड द पोजीशन ऑफ इलेक्ट्रॉन। समझ में आया? अच्छा, आके आप थे प्रेजेंट, समझ में आया क्यों पढ़ रहे हैं आके? आके को समझ में आया? हाँ, चलिए ठीक है। दिस वाज अ बिग, आई मीन अ कंप्लीट मिस्ट्री टू मी इन 11th स्टैंडर्ड। ये अचानक वेव कहां से आ गया भाई? हिस्ट्री ऑफ एटॉमिक स्ट्रक्चर ठीक चल रहा था, मॉडल 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 मॉडल, लैम्डा आ गया। ठीक है, सो देयर इज अ रीजन व्हाई वी आर लर्निंग अबाउट वेव्स। आंसर नहीं आया आप लोग का अभी तक, बहुत टाइम लगा रहे हैं आप लोग। दिस विल बी व्हाट 1 upon 58 into 10 to the power 8 into 10 to the power 2. This will be 1 upon 58 into 10 to the power -6. -6 will go above, it will become 10 to the power plus 6. 1 upon 58 will be approximately see guys 0.017, something around like this it will be there. 7, 8 or 7, 6 कुछ इस तरह से होगा. 10 to the power 6, it will be centimeter inverse. Okay, so if you want to write this in scientific notation, you can write this as 1.7 into 10 to the power 1.24 centimeter inverse. Got this guys? This will be tell me. ठीक है?
Yes sir.
A similar manipulation of equations only. ठीक है? Convert the units of nanometer to meter and so on. That's it. कुछ और ज्यादा इसमें complex problem नहीं आएगा. Now write next characteristic of electromagnetic wave. In characteristic of electromagnetic wave, we will write first of all, it consists of electric and magnetic field that oscillates in the direction perpendicular to each other. Direction perpendicular to each other. And both are perpendicular. I hope you remember this sign, perpendicular to direction of propagation. Okay, so let us suppose we have three axes, X, Y, and Z. Okay, so let us suppose that in one of the field we have the magnetic field. One of the direction, in the Z direction, let's suppose this is X, this is Y, and this is Z. In the Z direction, we have magnetic field. In the Y direction, we have electric field. The Y and Z axis will be perpendicular to each other, and both of them are each other perpendicular to each other. And X is the direction of propagation. Okay, that means they're traveling in this order, in this way, in this direction they are traveling. Now, how will the wave look like? So please see how, first of all, I am going to make the magnetic field. So magnetic field is upward, Z direction में, तो इस तरह से magnetic field, right? I hope you can see that it is moving in which direction? It is moving in X direction, but wave कहाँ पे? Wave आपके पास Z में, ऊपर नीचे, ऊपर नीचे, ऊपर नीचे, ठीक है? Similarly, for the Y, it will look something like this. Can you see the electric field? Yes or no? Please tell me. So there is a part of the wave which is responsible for magnetic character, and there is another part of the wave which is responsible for the electric character. आप इतना समझ लीजिए बस. There is a part which is responsible for the magnetism, उसमें magnetism नहीं होगा, and there is a part which is responsible for the electrical field. Okay, and both of them are perpendicular to each other, which is mutually perpendicular to the direction of propagation. All of you understood this? Yes or no? Please tell me.
Yes, sir.
No. A few more points. Did you write this down? Yes or no? Speed, as you know, it is 3 into 10 to the power 8 meter per second. And also one more thing, electromagnetic waves do not need any medium for propagation. And for example, light is also electron. Yes, it will be better if you draw this down. Okay, please draw this also. As you know, light is also electromagnetic wave, and it travels from sun to earth. And from sun to earth, we have vacuum. There is nothing present there, but it still manages to reach the earth, right? So it does not need any medium for propagation.
Done.
Now, electromagnetic waves, and there are different types of electromagnetic waves depending on their frequency and wavelength. And when you arrange them in the increasing order of frequency or decreasing order of frequency or increasing order of wavelength or decreasing order of wavelength, then you call that arrangement as electromagnetic spectrum. Okay. So we are now going to learn about electromagnetic spectrum. Please write electromagnetic spectrum. Now you will remember it like this. First of all, listen and then write. Okay. Listen first of all, don't write now. Cosmic gamma, cosmic gamma, cosmic gamma x UV, cosmic gamma x UV, visible IM. Cosmic gamma x UV, visible IMR. For cosmic, we have cosmic rays. Gamma this is a sign of gamma, gamma rays. After that comes your X rays. Then is ultraviolet rays. Then is visible region. In visible region, I will write VIBG or. Okay, violet, indigo, blue, green, yellow, orange, and red. And then I will write infrared. Then microwaves. And then radio waves. And then radio waves. Okay. So if you go from top to bottom, then what happens? Wavelength increases. Frequency decreases. And frequency and energy is directly proportional to, so energy also decreases. All of you done? Yes or no, please tell me. Please repeat this at 10 times at least. Cosmic gamma x UV visible IMR. Cosmic gamma x UV visible IMR. Cosmic gamma x UV visible IMR. You repeat in such a manner that you don't get confused. Okay. Cosmic gamma x UV visible IMR. This was a time I was in 11th standard, and recently only, you know, this Mahindra XUV. Mahindra XUV. You remember? You know this vehicle?
Yes, sir.
So recently only Mahindra XUV was new at that time. It's now an old model now, but Mahindra XUV was new at that time. And I think it was like when I was in 9th or 10th standard, maybe at that time it was launched. I think so. So in 11th standard, me and my friend were trying to learn this. So how to learn? So we said cosmic gamma x UV visible IMR. Cosmic gamma x UV visible IMR. I hope all of you are done. Yes or no, please tell me.
Yes, sir.
तुमने पढ़ लिया 10 बार, है ना? ठीक है. I hope याद भी हो गया होगा. दोबारा फिर से दोहरा लेंगे आपको. At least tomorrow you will revise this once again. Okay. Now, next is, now we have waves, obviously. Okay, we have waves, obviously. And all of these electromagnetic waves, they will be having some energy with them. The waves will be having some energy with them. And Planck was the one who was learning and trying to learn about the wave theory. So he said that, I will tell you with an example. Let us suppose, don't write anything right now. Let's suppose you are in a garden. And here you have a pipe. Okay. And pipe here, it has a hole. This pipe is connected to a water inlet. And once you turn on the water inlet, and let us suppose here we have a wall. Okay. Here we are having a wall. And this wall is newly built. So जब नया नया कोई wall बनता है, तो I hope all of you know that उसमें पानी देना पड़ता है. पता है आप लोगों को? नहीं पता है? हाँ. है ना? पानी देना पड़ता है. ठीक है, तो आप वही काम करने वाले हैं. नया नया यहाँ पे दीवार बनी है, आप उसे पानी देने जाते हैं. ठीक है. When you are going to start the water inlet, आप जैसे ही टैप को ऑन करेंगे, then water will start flowing like this. Correct, guys? Yes or no, please tell me. सही है? हाँ या ना? Now, tell me one thing. Is water continuously hitting the wall? Yes or no, tell me, guys.
No.
है ना? जैसे आपने ऑन कर दिया टैप को, वैसे पानी क्या करेगा? वॉल को स्ट्राइक करेगा, राइट? So it will be continuously hitting the wall. Yes or no, please tell me. हाँ. आमना, yes. आमना आप बताएं क्या? आकिब क्या ख्याल है? Yes or no, आकिब? Sir. जी, आमना बताएं.
Continuously hit करेगा.
Continuously hit करेगा. ठीक. अब ना क्या करते हैं? अब मान लीजिए आपके पास बहुत एक एक्सट्रीम लेवल का कैमरा आ गया, जिसमें आप लोग, I don't know, how much frame per second is good? अब्दुल हमीद, आप गेम वगैरह खेलते होंगे ना? 60 फ्रेम पर सेकंड इज क्वाइट गुड, आई थिंक, राइट?
90 भी अच्छा है.
90 भी अच्छा है. ठीक है. मान लीजिए आपके पास 1 लाख आ गया. कितना आ गया? 1 लाख फ्रेम पर सेकंड. ओके. एंड यू आर हैविंग अ कैमरा व्हिच कैन डू 1 लाख 1 करोड़ 10 to the power 23 frame per second. If you can go that, then you can see each and every water molecule hitting the wall, and that will be discontinuous. Yes or no? एक वाटर मॉलिक्यूल हिट करेगा, फिर दूसरा हिट करेगा, फिर तीसरा हिट करेगा. Yes or no, please tell me, guys.
Yes, sir.
So essentially, in reality, what is happening? It is discontinuous. That means it is discrete, right? One water molecule, then another, then another. ऐसा लग रहा है जैसे आप सेब फेंक रहे हैं. If you want to turn this into the macro level, it means in real world, if you want me to give an example, let us suppose you are throwing apples. You are throwing apples in the wall. So there are some times in which apple is not hitting the wall. So it is discrete. Discrete बोलते हैं उसमें ना, discrete, discontinuous. आमना and आकिब समझ में आया? हाँ या ना? In reality, what is happening? It is discrete. एक होती है continuous चीज. Continuous मतलब as a continuous, है ना? और discrete मतलब in packets, right?
Not
In small,
continuous.
small, not continuous. ठीक है? So obviously, hitting of water in the wall will be discontinuous in reality, even though it looks like continuous to us, but in reality, what it is? Amna, tell me. Amna, you understood this?
Discontinuous. Yes, sir.
Discontinuous. You understood, na? Completely? Koi confusion nahi?
No.
So similarly, similarly, Planck's quantum theory is there. He gave a quantum theory and he hypothesized that as this different things that we see and they are not continuous, similarly, he said that then nothing should be continuous. And he hypothesized that if we have a very hot body, he said that if I have a red hot body, what hot body? Red hot body. So this red hot body is going to release heat, right? Correct, guys? And
Yes,
if it
sir.
is going to release
Yes.
heat, he also said that that heat will also not be continuous. It will be in form of packets. ऐसे लगातार heat नहीं मिलेगा. Even though we may feel like we are getting heat continuously, but he hypothesized that in reality it would be in what packets. Got this, yes or no? Please tell me.
Yes, sir.
So write the topic Planck's quantum theory. Topic is Planck's quantum theory. What did he say? He said that he said that the energy emitted or absorbed, the energy is emitted, है ना? Emitted मतलब this red hot body is emitting the energy, or absorbed. If you are going to stay here, then you are absorbing the heat or the energy. The energy is emitted or absorbed discretely in form of packets. In form of packets of energy called quantum. Okay. Next, he saw that he had red hot body, and then he started to heat it. De Broglie law नहीं है ये आके. Oh my God. De Broglie law नहीं है ये. Not de Broglie law. वो आएगा बाद में आएगा. बोर मॉडल के बाद आएगा de Broglie. ठीक है, चलिए. So यहाँ पे ये कह सकते हैं कि next he saw that when he had heated a body, then it became red hot. And slowly he started to heat it even more, and then it became blue. है ना? As you know, the flame का सबसे highest, the most hot pot is what it is? Blue. And he
Yes,
said that,
sir.
okay, wait a second. With G-O, if I go from red to violet, the frequency is increasing and the energy is also increasing. Because unless and until I heat it more, I will not get red to violet rang. I will not get red to violet color. So he said that if the frequency is increasing, energy is also increasing. Then he said that, next thing, the energy associated with each radiation is directly proportional to the frequency of wave. That means E is directly proportional to frequency of wave. And if you want to remove the proportionality sign, I will put up a constant. E is equal to h nu. And he called this, h is known as Planck's constant. Further, we can write E is equal to hc upon lambda. The value of h will be equal to how much? It is equal to 6.626 into 10 to the power minus 34. Please remember, this is joule second, not joule per second, rather joule second. Okay. And also write one more thing, energy. What is E? This E is energy of one photon, one quanta. Energy of one photon. One photon is one packet of energy. अगर एक packet energy तो उसकी energy ये जाएगी. Then you are going to write for n number of photons. For n number of photons, E will be equal to nhc upon lambda, which will be equal to nh nu. This is Planck's constant. H is equal to 6.626 into 10 to the power minus 34. After many experimentations, he found out that. Okay. Can you write it down? Is everyone done writing? Is everyone
Yes,
done
sir.
writing? Now, write a note. Right. If E is given in electron volts, or you have to calculate E in electron volt and lambda in nanometer. Okay. Lambda in nanometer. Then if I plug in the values, E is equal to hc upon lambda, everything if I plug this in, then you can directly get energy is equal to 1240 upon whatever the value of lambda is. Okay. And 1 electron volt, this is equal to 1.6 into 10 to the power minus 19 joule. So you will get the energy here in electron volt. If you want to convert to joules, then you can just multiply 1.6 into 10 to the power minus 19. Whatever the lambda is. For example, make सवाल भी कर लीजिए. For example, calculate the energy associated with a wave of lambda is equal to 240 nanometer. Okay, so you can calculate this energy as E is equal to 1240 divided by 240 lambda. This will be in electron volts. You can cancel these two terms. Now 124 divided by 20 will be how much? This will be, if you do half, this will be 12. 124 is going to be how much? 62. Right? And this will be 6, and this is going to be how much? 31. Right? So this will be equal to 31 by 6 electron volts, right? 31 by 6 electron volts. Now, if you want to convert, अभी देखिए यहाँ पे decimal नहीं करना, joules में लेके आएंगे ना. तो जूल्स में लेके आएंगे तो 31 डिवाइड बाई 6, 1 इलेक्ट्रॉन वोल्ट इज हाउ मच? 1.6 into 10 to the power
1.6 into
minus
10 is minus 19.
this will be now in joules. Okay. Now you can cancel even more, right? So आप लिख सकते हैं 31 into 16 by 6 into 10 to the power minus 20.
20.
है ना?
Minus
16 और 6 कितना हो जाएगा? 3 जा, and this will be how much? 8 जा, right?
हाँ.
Approximately I can do 10 za, and this will be 80 into 10 to the power minus 20 joule. So I can write as 8 into 10 to the power minus 19 joules. ठीक है, तो इस तरह से कैलकुलेशन करना है आपने. Got this? Yes or no, please tell me.
Yes, sir.
Will you write this down? आमना समझ में आया आपको? आमना एंड आकिब, आमना आपको समझ में आया? हाँ या ना बताएं.
सर यहाँ से नहीं आया 31/6 EV.
यहाँ से नहीं आया. देखिए 1 इलेक्ट्रॉन वोल्ट कितना होता है?
1.6
इंटू 10 to the power minus 19 जूल. ठीक है, तो बस इलेक्ट्रॉन वोल्ट की जगह क्या लिख दिया आपने? 1.6 into 10 to the power minus 19 जूल. ठीक है
जी.
ओके. नाउ 1.6 को हमने लिख दिया 16. दैट मींस 1.6 है ना. 1.6 कब क्या है? 16/10. 16/10 यानी कि 16 into 10 to the power minus 1, और -1 और -19 में जाएगा तो कितना हो जाएगा? -20.
जी.
सही है. अब उसके बाद 2 3 जा 6 and 2 8 जा 16. सो 3 and 8 हो गया, और अप्रोक्सीमेटली हमने 3 को 31 से डिवाइड कर दिया 10 मान के. अप्रोक्सीमेटली क्या है? ठीक है.
ओके.
आगे समझ में आ गया? हाँ या ना? यहाँ से यहाँ तक
जी, जी, आ गया.
ठीक.